Hi, I'm Chip Burnham with Fairmont Machinery. As fiber laser power goes up, especially beyond 8 kilowatts, they cut faster and thicker. But there's a problem. Most machines can't move this quickly. For sheet metal, fiber laser machines are generally not quick enough to move the head as fast as the high-powered lasers can remove the material. Adding power is wasted on sheet metal when cutting on these slower machines. The best way to see your machine quickness is to cut 80 thou holes through something like 20 gauge steel. A rack and pinion drive machine is going to be half a G to 1.5 Gs. A linear motor is going to be 2 to 3.5 Gs, and an Eagle is up to 6 Gs of acceleration with its unique design in linear motor technology. It will cut 9 holes a second. That's as fast as many cluster punches. Every time you double the Gs, you cut the distance and the time to get up to speed in half. That's Galileo stuff, though Newton often gets credit for it. A hole is a great way to see acceleration because the X and Y axes are perpetually accelerating and decelerating. I hope this makes sense. Now let me show you on a 6G accelerating Eagle machine how this quickness and power relates to thickness. I've used this video for years to illustrate the marriage between power, acceleration, and thickness. It explains it so well. We're cutting thin material under 1/8 of an inch with a variety of power levels from 4 to 15 kilowatts. This is an intricate part about the size of your hand, and we're cutting with 4 kilowatts, 6, 8, 10, 12, and 15 kilowatts. When I hit play, you'll see how the bottom row cycle time will be the same. The bottom 3 cutting heads are moving like synchronized swimmers. Using more than 10 kilowatts is a waste. We'd use 10 kilowatts on this part and no more. This result is with an Eagle Inspire capable of reaching up to 6 Gs of acceleration. If it was a slower machine than this 6G accelerating Eagle, then the cycle times would be lower and there would be no benefit going up above, say, 6 kilowatts. Now, let's move to a thicker material. We're at 5 millimeters. This is about 200 thousandths or 0.2 inches thick. 2 important things you notice. First, the 12 kilowatts is cutting faster than the 10, and the 15 kilowatts is cutting faster than the 12. Raising power actually did decrease the cycle time. A second very important thing that you notice here is a little bit more hidden, but it's valuable to understand. With the very high acceleration of the Eagle at 6G, the cycle time for the intricate part will drop fairly proportional to the increase in power. Double the power from 6 to 12 kilowatts as you see here, and the cycle time approximately cuts in half. That's a rule of thumb, not a perfect law, but it's directionally correct. Quicker acceleration allows you to utilize power on thinner material. If you want to utilize laser power on anything other than thick plate, then you need a machine with up to 6G acceleration. You need an Eagle. Let us know if you'd like to see what an Eagle can do to dramatically increase throughput and profitability on your parts.